Hi, my name is Kamal, and today we are going to discuss the task-based applications and asynchronous programming. We all know that the processing power of the modern computers is encouraging us as a developer to design applications that execute tasks in parallel, utilizing the multiple CPUs of these computers. Type of the applications that is developed using the parallel programming is called parallel applications. .NET Framework makes the parallel programming simpler by introducing a TPL, a task parallel library, which is set of public types and APIs in the system.threading and system.threading.tasks namespaces. TPL library provide the task class in the system.threading.tasks namespace, which is representing an asynchronous tasks in a program. Programmers can use this class to invoke a method asynchronously. We will see how to deal with tasks in action in a moment. Now, let's get down to business. In this example, I have two methods, method 1 and method 2. They are dumping messages to the console, and method 1 is pausing to 3 seconds. Okay, in the main, I invoke method 1, method 2, and just dumping the message end of the main. If I run this program, this command is executing sequentially. Why? Because this type of programming is called synchronous programming or sync programming. So let's see. If we started our code, method 1 is started, pausing for 3 seconds, and then method 1 is finished, method 2 has started and finished, end of the main. So method 1 is finishing it is execution, and then we jump to method 2. After finishing it is execution, we jump to the console.writeLine end of the main. As I told you, this is traditional programming or synchronous programming, and the code is going to be treated sequentially, line after line. That is the normal programming. Now we are going to change this example to work with asynchronous programming, where we execute the commands concurrently or in parallel. Okay, in our previous example, we have seen how to use asynchronous programming to execute our code sequentially. Now we are going to test asynchronous programming. To execute or to implement asynchronous programming, we have to use the class tasks, which is belong to the namespace system.threading.tasks. So right now I created task 1, task 1 equal new task, and I have passing the method 1 as a parameter to the constructor of the task. This method is going to be converted on the compilation time to a delegate of type action, because the method is receiving no arguments and returns a void. Task 1 is created and then started. When we start this task, this method is going to be executed, and the execution is going to be in a thread in parallel. Okay, task 2 equal new task 2, but the difference here is using the delegate action, and namely I created an object of the delegate on fly, and I passed method 2 to the delegate. This delegate is going to point to method 2. So when we start task 2, method 2 is going to be executed. And at the main thread we have console.writeLine end of the main. If we run this program, we will see the difference from the previous version. Look, end of the main, method 1 is started now, and then method 1 sleeping for 3 seconds. We will leave it as a sleep method, and we jump directly to method 2 started and finish it, and then method 1 after completing the 3 seconds is going to continue with its commands, which is printing method 1 is finished. Okay, this is what we call it asynchronous programming, or parallel programming using the class task. So as we've seen in the previous execution of this code, the main thread is finishing its execution before task 1 and task 2 finishes their execution. And this is not a good idea if you have some code depending on task 1 and task 2 at the main thread. So to prevent this, I will call a method wait on task object t1.wait and t2.wait. What does this mean? This means that execution of task 1 and execution of task 2 must be completed before the main thread is completing its execution. Let's see the running of the code. Method 1 is starting now. Method 2 has started and finished. Method 1 is finished, and then end of the main. So to make this code compact, I can remove this 2 lines and make it a 1 line by using the static method wait all, and wait all is always receiving an array of tasks to be waited. So if I execute my code, I will get the same result. Okay, so another example of creating a task is by using a run static method. So I have 3 methods here: addition, subtract, and multiply. Addition has some lines of code dumping some messages on the screen. Addition has started. Addition sleeps 4 seconds, and here Ariel is sleeping in 4 seconds, and then addition is waking up now after the 4 seconds. Return x plus y, which is 37. Subtract is doing no subtraction, but dumping the message on the screen and returning 25. Multiply doing the same stuff, no multiplication, but returning 35 after dumping the message. This is our methods. I will convert this method to a task. I created a method called caller, and now to create task 1, I have used the method run, which is creating and starting the task at the same time. I am not going to use the start method to start the task. Run is creating and starting the task at the same time. So task 1 is going to execute addition method. Task 2 is going to execute subtract. Task 3 is going to execute multiply. At the main method, which is the entry point of the console application, I invoked the caller method. Let's see the execution of this code. Look, addition has started. Addition sleeps 4 seconds. Subtraction has started and finished. Multiplication has started and finished. Addition is waking up now. After 4 seconds, addition is waking up. So I did this by using run method. If there is one of these method depending on the other, let's say subtract depending on addition, depending on the result returned by addition. So how to let the method subtract wait until the addition is executed? That is what we see in the next example. So in this example, we are going to change our code a little bit. Our subtract method is receiving an argument of type int and retains a value of result minus 25. So subtract method is not executing until task 1 is completing its execution. To do that, we will change the code of the caller a little bit. Here is our task 1, and task 3 will remain as it is. There is no change on their code. But I will add object of an awaiter var aw equal task1 dot get awaiter. This awaiter is making sure that task 1 is completed to start subtract method execution. So to do that, I will use the awaiter object dot on completed. This is means that if task 1 is completed, then we will execute this lambda expression. The lambda expression is a callback function which is going to do the following: is getting the result of task 1, which is 37, and then executing subtract method by passing it the result and returning the value in C, and then dumps the value of C in the screen. This code means that subtract method is not going to be executed until task 1 completes its operations. So let's see the execution of this code. Now addition has started. Addition sleeps 4 seconds. Multiplication has started and finished. Addition is waking up. Subtraction has started and finished, and the result is 12. It's the difference between 37 and 25. Look, this code is more readable in context of who is going to be executed first. Task 1 is going to be executed first, and the other task is going to be wait until task 1 is finished, especially subtract method. So this code is more readable because we are creating an awaiter, and then the awaiter is going to make sure that the task is completed, then calling the method subtract. I will change this to a modern technique using async and await keyword. So I will delete this code because it's a lot of code here, and I want to see my code feels like synchronous programming, but at the same time it is asynchronous code. So here I will say that this method is async method. When I added the async method to the signature of the method caller, the method now is complaining. It is complaining because this method must at least contains a wait keyword on its body. So I will do it here. I will say that var task1 is going to be awaitable. Task1 var task1 equal await task.run, and then calling the task that we want to do their operation with it, and then I will get the result of subtraction and dump it on the screen. Subtract, and I will pass the value of task 1 to subtract. Okay, this is means that this line of code or this lines of code is not going to be executed until this method is finished. It is execution. Until this task is finished, it is execution. So let's see the execution. I will run the program here. Addition has started. Addition is sleep 4 seconds. Addition is waking up now. Subtraction has started and finished. The result is 12. And then the last line is that multiplication is started and finished. So await keyword is doing the same thing that we created with the awaiter object, and on a completed action, which is receiving a callback as a lambda expression. Here I use just async and await keywords to do that. We will see more about async and await keywords in asynchronous methods in the later examples. Yeah, so async and await keywords are one of the TPL library, which is helping us to create asynchronous methods and achieving the goal of asynchronous programming. Um, you have to use asynchronous method and asynchronous programming for the operations that takes long time. For example, if you have a call to a web service which is retrieving a lot of data from a web service or something like that, you can use an await and async method to achieve this goal. If you have something you want to read from any remote source which is taking long time, also can be achieved with async and await methods. So if you like this video, please hit like and subscribe, and thank you for your patience. We will see you in the next video, inshallah. Bye.